So welcome to the ONF Spotlight on 5G Connected Edge Cloud for Industry 4.0 transformation. We have another esteemed speaker today to present to you, and he needs no introduction to the ONF or the SDN community. Kang-Won Lee has been involved and a pioneer with SK Telecom in SDN and 5G and other projects with us for many years. For people who may not know him, he currently heads the product and R&D departments around the 5G cloud and MEC, and we are going to hear about the 5GX Cloud Labs from him. Before going back to Seoul, Kang-Won was at IBM Research for 14 plus years, and before that he did his PhD at Urbana-Champaign. So he's a familiar figure to us, and welcome, Kang-Won. Great to have you back at the ONF events. You have been speaker at ONF events multiple times, and this is great to have you back.
Yeah, thank you, Asim, and thank you for having me. It's my great pleasure to talk about our development effort in the space of 5G mobile edge cloud, edge computing, and what we have done so far, and what are the use cases that we have looked at, and what is our plan for the future. So let me start. So MEC can be interpreted in many ways because a lot of people talk about MEC, call MEC as a multi-access edge compute. In SKT, we think MEC is mobile edge cloud. And especially with the advent of 5G. In Korea, we started 5G in last April, and we have crossed 10 million 5G subscriber mark recently in this country. And we are looking at more and more demand for having this compute capabilities at the edge of the network. But we just didn't want to stop at the edge compute because many cases, customers, whether they are enterprise customers or whether they are government customers, they don't want to have steps and they don't want to have complexity to manage servers and storages in their buildings and their sites. They want cloud capabilities in the sense that they want to just use the computing capabilities, and the services need to be provided by someone else. And we think there is an opportunity to provide edge cloud there. So in short, what we are seeing is there is a general trend that people want cloud computing capabilities near their 5G users. And this 5G mobile edge cloud that SKT has been developing and deploying is basically to provide ultra wideband service with ultra low latency, and also provides data security, because in a lot of the cases, the data needs to remain on site, and this 5G MEC is a perfect infrastructure to provide those requirements. So as you can see on the left side figure, we used to have all these smart services like AR, VR, games, and self-driving and internet banking in the public cloud. Now in order for the devices to access them, we had to go through first wireless part of the network than the best effort internet. Now, by bringing these compute and the cloud capabilities at the edge, these services can reside in the edge and can be served from the edge right away. So that is the vision. And this can obviously reduce the network latency and also improve the expected network quality, because as you move from one hop to the next hop, you have the chance of performance variability in the network. But by moving these services at the edge, we can have much better predictable network performance. And also, in case when these services are really close to the network and the base station, and with the full 5G enabled, then the network latency can go as low as single millisecond. So this is a huge benefit for certain critical applications. And we are not there yet, but we are moving towards that goal. And this is also a very interesting trend for traditional public cloud service providers. And they want to also come into this domain. And there is a lot of opportunity for telcos to work together with these cloud service providers. At SKT, we have two main deployment models. So one is something called the public edge. And this is a MEC deployment model where we deploy these edge cloud infrastructure to our central offices. And by doing that, we can provide nationwide MEC services to our 5G users. And they can be very good scenarios for B2C use cases like AR/VR or video or cloud gaming or self-driving cars and machineries. Another deployment scenario is something called on-site edge. And this provides private MEC services to enterprise and government users. And this can be a very good scenario for smart factories and smart hospitals and offices and branches and so on. In both these scenarios, SKT has, we have been always been open to collaboration with communities and open source development groups, and also big partners like other companies like AWS and Microsoft. So we are collaborating with them to provide their capabilities, not just our MEC, on our sites, so that users can have ultimate benefit. Okay, so recently a lot of telcos are starting the MEC effort, and there are a few things that SKT is probably different in the MEC space. So the first one is the edge infrastructure. So we have started developing MEC platform management and the Biz console for application lifecycle management. We have been developing about 2 years now. So, and we have deployed them in our public MEC and working on the on-site MEC. So it is quite, and we have gone through multiple iterations. So I think we have started this effort relatively earlier than the other operators. The second point is this, as I mentioned in the previous slide, we are working with the public cloud service providers so that we can provide their services and APIs in our MEC. Third one is that SKT has a lot of tech assets, and from the services that we provide, like smart speakers and the navigation service, blockchain-based DID service, and cloud robot service. And we can provide these assets as API in the form of APIs and the SaaS and PaaS to our MEG users. We also have telco APIs, and these can be used by application developers that uses, say, users' location information or the device information and so on. We are working with other operators and the device vendors and also GSMA and ITU, so that our MEC is not just for SKT, but also it can be used by other operators, and also it can be standardized so that we can have federation of MECs. So, we feel that it's very important that we work with the ecosystem so that this MEC can become a really useful solution for end users. Next slide. Basically, this is a overall architecture for anyone who understands the 5G network infrastructure. So the left-hand side, this part is the 5G network, and we have MEC gateway. And this is connected with the compute and storage resources. Basically, these resources connected with the tech assets that we provide, and also we are connecting them with the public cloud service providers services. And we have a federation of MEC going on with the other operators. Again, this is a little bit more zoom in on our MEC architecture. So on the left-hand side, there is this radio components to process 5G. And then in our MEC, we have first virtual infrastructure for virtualized compute and storages and networks. We support all forms of compute resources, bare metal, VMs, and containers. And we have a special component called edge stack, which I'm going to describe a little bit more in the next few slides. And then we have connectivity between 5G gateway and our MEC. And we have a component called MEC router that can process different protocols and also do traffic steering and the load balancing and so on and so forth. Then we have different applications that will go on top of MEC. And this will get traffics from the 5G network. And they can be machine vision or virtual mobile infrastructure or cloud gamings. They will be managed by this MEP manager. MEP stands for Mobile Edge Platform. And this will be now, they will connect with the service gateway for different types of services that they can call. And all of these MEC and the rest of the infrastructure will be handled by MEC director and also this console. So this is the overall MEC architecture that we have built. I'm going to talk about a little bit of this yellow component called the edge stack. And I think this is fairly unique to what we are doing. So We have designed SKT MEC to support cloud native applications. And for that, we felt it's very important to be able to support containers and manage Kubernetes services so that developers and users can effectively deploy their pods and have CI/CD infrastructure. A lot of the challenges is that there are many different managed Kubernetes providers, and also running this Kubernetes containers on top of VM, there are some performance penalties. So we try to address these issues by having a component called Edge-Tron and also Singular's network stack to provide managed Kubernetes for MEC using Edge-Tron, and provide zero penalty network performance using Singular's network stack. So I'm going to give you a little bit of description about these two components, technical components. So Edge stack, this is like a bird's eye view of the Edge stack, and all of these components will be part of the MEC infra that I just described to you. So there are container platforms and there are virtualized infrastructure, and we have Edge stack, and this Edge stack interacts with these virtual infrastructure and containers, and also it interacts with the MEC orchestrator through this Edge interface. And this Edge stack has Edge-Tron, which works with the cluster API providers, and there are many different ones. I'm going to give you a little more architectural diagram in the next slide. And also there is this Singular's network stack, which includes SONA and SONA CNI. If you have been involved with the ONF and the ONOS community, then you might also know SONA is our contribution to the ONOS community. And basically we have evolved this to make it work nicely in the MEC environment. So I'm going to give you a little bit more description about that. So Edge-Tron is basically a cloud native resource management for multi-cloud edge. And it abstracts provider specific cluster lifecycle management mechanisms using the cluster API. So these MEC platform manager and orchestrator, it can talk to Edge-Tron, and Edge-Tron speaks cluster APIs to different container management platforms like KVM with vanilla Kubernetes, or Kubernetes with OpenStack, or VMware Tanzu, or Amazon EKS, and so on and so forth, to actually create Kubernetes clusters inside MEC so that it can work, it can provision Kubernetes clusters and pods, and then make applications work on those clusters. So that is Edge-Tron. The next one is a Singular's network stack. And basically this is an SDN-based optimized network stack for managed Kubernetes. So in many cases, what happens is that inside, for managed Kubernetes, we have host VMs that has OVS, and then on top of that, we have VMs, and that has many container pods. And there is an overhead of having virtual network stacks inside the VMs and also the host VM. And what we try to avoid is any overhead that is incurred by having these virtual network stacks. And we are controlling that using SONA for VM OpenStack management, OpenStack networking management, and SONA CNI for Kubernetes network management. And basically having them through this through these management interface, we can configure the VMs networking and the container networking. So what this slide show is that first, I mean, this is the traditional managed Kubernetes stack. So basically you have host and you have host vSwitch, and inside VM there is another VM networking stack and then Kubernetes networking stack. And these pods basically, in order for them to talk to each other, they have to go through these networking stacks. With Singular's network stack, what we have designed is to bypass these VM networking stack inside the VM for the container, and we can just connect directly. And by having this configuration, as you can see with the Singular's network CNI, we can have much higher throughput than the traditional managed Kubernetes scenario. So you can see up to 6 times throughput improvements. And also this can reduce the latencies for large size frames, which is important for many MEC applications. So there are several MEC business cases that SKT has been working on. This year we have about 20 MEC industry use cases, and we are working with those customers. They include both B2B use cases, like in the below, and also B2C use cases, like on the top. So for B2C use cases, there are cloud VRs, massively interactive ARs for gamings and others, and the online education and the smart buildings. We have also cases like smart factory, government scenarios, smart robots, and smart hospitals. So in the next, I'm going to just show you one illustrative scenario that uses ultra low latency and reliable capabilities of 5G and AI processing capabilities at the MEC site. So this is a machine vision scenario. I'm going to play the video. And this is one of the cases that we have developed early on in our 5G cases. So this is one of the customers that manufactures automobile parts, and they have people dedicated to looking at these parts for scratches or dents and determine whether they should be accepted or they should be rejected. And what we have done with this customer is by using MEC, we have this antennas and the compute capabilities on their site, very near to their the conveyor belt, and using AI machine vision sensors to determine whether they pass the quality test or they fail. So this was one of the cases that we have shown, and that it can work to reduce the overhead of trying to determine this manually. Also reduce the error rate for determining the determining the quality control, and also basically show that, okay, this type of work can be done using MEC, using 5G. There are lots of other use cases that we are developing in the space of smart manufacturing, and where there are data sensitivities for the company. So they deploy VMIs, virtual mobile infrastructure, so that it's similar to virtual desktop, except that the use case is for your smartphones. So employees can have smartphones on their sites, but they are sort of, separate from the regular network, so that you can have total control of the security and data flow. We have, in order to manage our MEC, we have developed MEC operation and app lifecycle management system. So as you can see, there are these type of dashboard where you can select one of the MEC sites, and then you can see the compute and storage and network resources like you would see from the cloud view. So you can treat these virtual resources as your cloud infrastructure, and then deploy applications on these virtual resources, and then configure them, and then manage the application. And also, if you upgrade the application, you can deploy them. We are working to make sure that the deployment can be done automatically. And also we are supporting this service mesh, so that we can provide the CI/CDs and also canary test and application rollback type of regular services that you would expect from any modern app application development at the edge site. We are actively working with global MEC ecosystems and players in this space. Like I mentioned, a lot of the public cloud service providers are interested in the mobile edge, so we are actively working with them. We work with global operators and the Operator Alliance, and also organizations like GSMA, so that we have opportunities to deploy these MEC technologies and work together as a federated MEC. We are actively working with vendors like Samsung, Intel, HP, and Dell, Cisco, Ericsson, so that we can develop this MEC in a coordinated manner. And we are working with other industry, government, public services, and startups, so that we can create interesting new use cases. And also we are trying to tap into opportunities to deploy these technologies if there is any interest in other parts of the globe. So we feel that MEC is a new area where telcos can play an important role. Software, especially this SDN and open software ecosystem, can play a key role. And last but not least, startups with new ideas for 5G, they can have a lot of, they can make a lot of differences in this space. So we are actively seeking opportunities to work together with them. So with this, I'm going to conclude my talks. I have listed some of the awards that we have recently received on this effort. Thank you.
Thank you very much, Kang-Won, for the talk. It was very exciting, and to learn about this new initiative. You seem to have come a long way already in this. Yeah, so let's have a quick discussion. I want to highlight a couple of things I heard in your conversation, if you want. So the first question is: do you consider this a product or a kind of a proof of concept of an idea? How does SK Telecom see this? Looks like a product, but I just want to confirm.
Yeah, I mean, we have deployed our public MEC in 4 sites this year.
Okay.
And there is a lot of there's a MEC services being tried on. So MEC is productized. The services are many of them are in POC stage. Some of them are very close to commercialization and productization. And we are working with cloud service providers like AWS. It's a publicly announced, so I can talk about it. So, and it's going to be, the service will open soon by the end of this year.
Okay, and obviously this is a platform, so it can serve multiple industries. But is there a particular vertical industry which you've seen the most traction or the most applicability of MEC so far?
Very good question. So we have been talking to a lot of enterprise customers and government customers as well. So far, the customers that have shown interest are customers who have data sensitivity, so data privacy. So lots of manufacturing customers, finance and bank institutes, and also hospitals. So they have the first use cases. Other customers they are interesting is broadcasting, media broadcasting, cloud gaming, and also robots. So cloud robots. So delivery robots, robots to detect, say, COVID-19 threat in the airport.
Right.
So yeah, so there are those type of scenarios.
Right. So I think that from the examples you cited, there are 2 types, right? So one is the data privacy, manufacturing data, hospital patient data, which has regulatory information. They are less likely to, my guess is, to use public cloud and hence also the public edge. Is that correct? So they would like to deploy it on their site, right? Like you said in your example, right next to the conveyor belt or wherever you were showing in the video, right? So that's where so in that model, I totally understand the data privacy kind of being, and the latency, low latency being the most important part, right?
Yes.
Okay. But in the case where you are going to the public MEC site, right? Where in this 4 or 5 sites which you have deployed today, how does the user, does he ride the standard mobile network, or does you create a private mobile network for the edge, the customer himself? So is there a private mobile context also put in? No, there's no.
No, it's a public edge, and so it should be able to serve any 5G users.
I see. And similarly for the even when you go on site, you are looking at using just the public 5G spectrum, right?
Right. In Korea, we don't have dedicated spectrum for private 5G.
Like the CBRS kind of things, okay.
No.
I see, that makes sense, okay. Good, no, I think it's makes perfect sense in that environment. Couple of other things I noted while you're talking was this 2 pieces of innovation you brought together, Edgetron and Singular Net Stack. So these are all your own creations, right? These are you?
Yes. In our team, basically, You know, I mean, we have been working on Sona,
Yeah,
which
that
is,
part, yeah,
yeah.
correct. Right,
So, I
makes
mean,
sense.
this has been evolution from that effort. Basically, we have created this Sona as an interface to control OpenStack based virtual networking, right? And we have evolved to container networking. So that was last year. And this year we have looked at more on the edge networking and how can we combine these basically pieces that have been developed in different contexts and put them together so we can create nice environment where the user can use any type of managed Kubernetes that they choose to.
Mm-hmm.
Then if they choose our managed Kubernetes,
Mm-hmm.
then what type of networking, I mean, performance benefit they can get is basically where we
But if
have
they
created this. Yeah.
I see. If they choose yours, you provide the full
Full,
container
yeah,
management, resource
yeah,
management, everything,
yeah,
right?
yeah,
Yeah.
integrated, yeah,
But if they wanted
capability.
to choose Azure or AWS as their kind of their
Then they
host,
will have to go through their networking stuff.
I see. So then
Yeah.
you just provide the connectivity service in that scenario.
We provide connectivity service, and we can also provide provisioning and all the full management through cluster API.
Okay.
But the Singular's network stack is not in there.
I see. The
Yeah,
network
so that
stack is
part
not there, nor is the Kubernetes can manage Kubernetes service really delivered through you.
will
So they
be
would
done through their interface.
make sense. Makes sense.
Yes.
But that's wonderful that you have been able to bridge all those different hybrid cloud environments together, so that for
Yes.
the
Yes. Yes. So far, we have done that with VMware because
Mhm,
we have started collaboration with them,
mhm,
Dell and VMware, on
mhm,
the MEC side,
mhm.
and the AWS and the Azure integration will come soon.
Very good. No, we're looking forward to exciting announcements in the future. This looks like a very interesting project, and uh, there are a lot of similarities in how ONF is also kind of approaching this problem set.
Yes. Yes.
Love to collaborate at the right times with that. So I think thank you again for the nice talk. Appreciate your taking the opportunity to tell us about 5GX labs and the
Yes. Yes.
whole MEC initiative there. And looking forward to more news and more talks from you in the future.
Okay, thank you so much for inviting me to this wonderful event. Wish you the best and stay safe.
Thank you.